An identity matrix is a matrix that has a 1 in every main diagonal entry, and then in every other entry it's got a 0. The main diagonal is where the row and column numbers are the same. So this is the 1, 1 entry, and the 2, 2 entry both get 1s, and then all the other entries get 0s. So this is a 2 by 2 example. If you had I3, then you would have 3 vectors in your matrix. And along the main diagonal, you have 1s, and then everywhere else you have 0s. Now the columns of these identity matrices are what we call the standard basis vectors. So if you take an engineering or physics, you might call these I, J, and K, right, in 3 dimensions. In 2 dimensions, 1, 0, we would call that E1, 0, 1, we'd call that E2. And in 3 dimensions, 1, 0, 0 would be E1, and then this 0, 1, 0 would be E2, and 0, 0, 1 would be E3. And in R4, you'd have an E4, and it would be 3 zeros and a 1, right? And on and on and on it goes. It turns out that if you have a linear transformation, let's call it T, and we want to find the standard matrix, we can actually perform the transformation on these standard basis vectors, and the output that we get will be the columns of the matrix. So the first column of the matrix we could find by taking the transformation of E1, second column would be the transformation of E2, and until we use up all the standard basis vectors. Now, how do we know how to take these transformations if we don't have A? So usually we'll know what we want to happen. So we want our transformation to do certain things, like in the last video we talked about the derivative. We could have a transformation that takes derivatives. So we have to know what the transformation is supposed to do, and then we just do them to the standard basis vectors, and then we put those vectors into the columns of our standard matrix. So let's do an example. It says find the standard matrix of the linear transformation that rotates a vector in R2 60 degrees counterclockwise and reflects across the x-axis. So we're going to draw a picture. We know what the transformation is supposed to do, and we want to find a matrix that will do the operations for us. So we know that we want to rotate 60 degrees counterclockwise, and then we want to reflect across the x-axis. So we just want to do the transformation to E1 and E2. So we'll start with E1. This is 1, 0, right? It's here. And we're going to reflect it 60 degrees. So that will be something right here. So this would be 60 degrees. And then we're going to reflect across the x-axis or the x1 axis. If we reflect it, we get this vector, and this would also be 60 degrees. And this is counterclockwise, right? So this way is counterclockwise. We rotate it, and then we reflect it across the x-axis. So this would be T of E1. And this is in the 4th quadrant. And we're sitting on the unit circle because E1 has a length of 1. And we're just rotating and reflecting, so we're not changing the size of the vector. So this vector is also sitting on the unit circle, and we know that it's at 60 degrees. So this is going to be cosine of 60 degrees, sine of 60 degrees. In the 4th quadrant, cosine's positive and sine's negative. So I'm going to call this negative sine of 60 degrees. So we just need to remember our trigs. That's going to be 1/2, and this is negative square root of 3 over 2. So in our standard matrix, that is our first column, the transformation of E1. So now, since we're in R2, we just have to do this for R2. So I've got E2 would be here along the y-axis or x2 axis. This is E2. It's 0, 1. We're going to rotate it 60 degrees this way. That means this angle is 30, right? The angle between the vector and the x-axis. And then we're going to reflect that across the x-axis, so we'll get this vector. And again, that angle with the x-axis will be 30 degrees. So this is t of E2. And again, we're on the unit circle, so this is going to be cosine and sine of 30 degrees. And since we're in the fourth quadrant, both of these will be negative. The third quadrant. Both are negative there. So that is going to be negative square root of 3 over 2 and negative 1/2. So that's our second column. So that's our standard matrix. So let's just check and see if the matrix actually does what we want it to do. Let's pick a different vector. What's t of how about cosine of 30 degrees, sine of 30 degrees? So that would be square root of 3 over 2 and 1/2. So we need to just multiply our matrix A times this vector. Right, so I'm just going to use the dot product method here. So I got 1/2 and square root of 3 over 2. So that's square root of 3 over 4 minus square root of 3 over 4. So we're going to get 0 there. And this one's going to be negative 3/4. And this is negative 1/4. So that's going to be 0, and that's going to be negative 1. 0, negative 1. So let's see if this actually works. So my vector that I plugged in, this root 3 over 2, 1/2, it's this vector on the unit circle at 30 degrees. So this is 30 degrees. This is our square root of 3 over 2, 1/2 vector. So if I rotate it 60 degrees, I'll be on the y-axis. And then if I reflect across the x-axis, it will reflect down here. And yeah, that is 0, negative 1. So the matrix did what it was supposed to do. So let's do another example. Find the standard matrix of the linear transformation that is a vertical shear transformation that maps E1 into E1 plus 3E2 and leaves the vector E2 unchanged. So again, I just need to know what's T of E1 and what's T of E2. It says it leaves E2 unchanged, so we're just gonna say E2 is unchanged. And for E1, it's going to be E1 plus 3E2. So E1 is 1, 0. E2 is 0, 1. So if I add these together, I get 1 and 3. And E2 is just 0, 1. So A would be 1, 3, 0, 1. And that matrix should do this vertical shear transformation. Okay, now find the standard matrix of the linear transformation that reflects across the x1 equals x2 line and then rotates the vector 45 degrees counterclockwise. So again, let's make a picture. E1 is here. And what is x1 equals x2? Well, that's x equals y, or y equals x. So there is a line going through, right, at a 45-degree angle. So this would be x1 equals x2. Right, this is the x1 axis. This is the x2 axis. So it's going to reflect across that line. So if I reflect there, I get this vector. And then rotates 45 degrees counterclockwise. So that would be 45 degrees there. So this is T of E1. So what is this vector? So it's a 45-degree angle. In quadrant 2, cosine's negative, sine's positive. So this is going to be negative square root of 2 over 2 and positive square root of 2 over 2. So that's cosine of 45 and sine of 45 degrees. Cosine's negative in quadrant 2, sine's positive. So that's my first column of A. And next, let's do E2. So E2 is here. If I reflect across the x1 equals x2 line, I get this vector. And if I rotate 45 degrees counterclockwise, my vector's sitting on the y equals x line. And it's at 45 degrees, so T of E2 will be just the positive square root of 2 over 2, because sine and cosine are both positive here. That's cosine and sine of 45 degrees. So there's my standard matrix.